Next, continue the properties. Prove that the following. So first property is cos inverse minus x equal to pi minus cos inverse x. Here condition is x belongs to closed interval -1 to +1. Second property is cot inverse minus x equal to pi minus cot inverse x. Now same case, third property is sec inverse minus x equal to pi minus sec inverse x. Now let us prove one by one here. Now first property is cos inverse minus x equals to pi minus cos inverse x. Its condition is x belongs to closed interval -1 to +1. Next, now this implies here we have to take or let minus cos inverse minus x equal to take cos inverse minus x equal to theta. Take it on called equation number 1. Now this minus x keep as it is there only. Inverse trigonometric functions move right hand side, it become trigonometric function. So cos inverse move right hand side, it become cos theta. If minus x equal to cos theta means x equals to minus cos theta. Now here we have to replace the value for minus cos theta. You have to cancel out this negative sign. Outside negative sign is there, we have to cancel out this negative sign, means replace its value. So that is, now this implies x equals to cos cos 180 minus theta equal to minus cos theta is there. So cos pi minus theta, 180 means pi. So cos pi minus theta equal to minus cos theta. Here we have to write down, because cos pi minus theta equal to minus cos theta. In place of minus cos theta, we put cos pi minus theta. Now further, this cos function move left hand side, it become inverse, because this is trigonometric function is there. So trigonometric functions move left hand side, it become inverse trigonometric functions. So that is cos inverse x equal to pi minus theta. Now this minus theta move left hand side, it become plus theta, and pi keep as it is there only, and this plus cos inverse x move right hand side, it become minus cos inverse x. Take it on called equation number 2. See the equation number 192. From 1 and 2 we get, see the equation number 1, LHS is cos inverse minus x. Cos inverse minus x equals to, replace the value for theta. See the equation number 2, theta value is pi minus cos inverse x is there. So pi minus cos inverse x, hence the proof. Its condition is x belongs to closed interval -1 to +1. Now same case, let us prove the properties of second property, that is cot inverse minus x equal to pi minus cot inverse x. Second one is cot inverse minus x equals to pi minus cot inverse x. X belongs to R here. Now take cot inverse minus x equal to theta. Cot inverse minus x equal to theta. Take it on called equation number 1. Now again minus x keep as it is there only, and this cot inverse move right hand side, it become cot theta. If minus x equal to cot theta means x equal to minus cot theta. Here also you have to replace the value for minus cot theta. Now this implies x equal to cot pi minus theta. Cot pi minus theta equal to minus cot theta, because cot pi minus theta equals to minus cot theta. Now further this cot move left hand side, it become inverse. Cot inverse x equals to pi minus theta. Same case. Now this implies theta equal to pi minus cot inverse x. Take down chord equation number 2. From 192 we get, from 1 and 2 we get cot inverse minus x equals to pi minus cot inverse x. Hence the proof of second property. Now same case you have to prove third property. Third property is sec inverse minus x equals to pi minus sec inverse x. Now same, let or take sec inverse minus x equal to theta. Let sec inverse minus x equal to theta. Take down called equation number 1. Repeat same procedure. Minus x keep as it is there only, and inverse trigonometric function move right hand side, it become trigonometric function, that is sec theta. And now this implies x equal to minus sec theta. Replace the value for minus sec theta, so its value is x equal to sec pi minus theta. Sec 180 minus theta equal to minus sec theta, already we know, because sec pi minus theta equals to minus sec theta. Now again this sec function move left hand side, it become sec inverse x equal to pi minus theta. So finally theta equals to pi minus sec inverse x. Take down called equation number 2. From 192 we get sec inverse minus x equal to what? Pi minus sec inverse x. Hence the proof of third property.